Okay, so in today's video we're going to cover the alternating series test. This is a very useful test because oftentimes you'll find series that fluctuate between negative and positive terms, and therefore other tests are not applicable. However, in one of these cases we can use the alternating series test. So suppose we have this series a sub n, and either the series a sub n equals negative 1 to the n b sub n, or the series a sub n equals negative 1 n plus 1 b sub n. And in a later video we can prove that any series can be rewritten as either of these. So assuming that's true, then where b is greater than or equal to 0 for all n. So then, if first the limit as n approaches infinity of b sub n equals 0, and 2, that this b sub n is a decreasing series, or in other terms we could say b sub n is greater than or equal to b sub n plus 1, then we meet the criteria for the alternating series test and subsequently begin. So, say we have a series from n equals 1 to infinity of the quantity negative 1 to the n plus 1 over n. Now, this can simply be written as negative 1 to the n plus 1 as up here, and then we need a b sub n, which is simply 1 over n. So in this situation, our b sub n is simply 1 over n. So, following the first criteria, if we take the limit as n goes to infinity of b sub n, or 1 over n in this case, we need to get 0, which in fact we do, because 1 over an infinitely vastly large number is simply 0. So then we approach the second criteria. B sub n, which is simply 1 over n, needs to be greater than or equal to b sub n plus 1. So if we take n plus 1 in this case, which is b sub n plus 1, we need to see if this is true. And in fact it is, because if you take the denominator and add 1 to it, it's going to be a larger number, but because it's in the denominator, it's going to make this smaller number than this. Therefore, both of the criteria for the alternating series test are in fact met. We can assume that this alternating series test, or in this case, this series, in fact, converges.